Hey guys, this is Chapter 7, Section 3 and 4. We're going to talk about acids and bases in the pH scale. So acids and bases, we use things called indicators. We use the litmus paper, the red and blue litmus paper, and they turn a certain color if they come in contact with an acid, or in a different color if they come in contact with a base. So when you're looking here, acids, the red and blue litmus paper will both turn red. And for bases, the blue and red litmus paper will both turn blue. So always remember, bases, blue. The acids, the properties of acids, it turns blue litmus red. It tastes sour. Think of lemon. It reacts with metals to make hydrogen gas, and it can be corrosive. It has an H+ ion. It donates hydrogen ions, and it has a pH less than 7. The strongest acids will actually be 1. They're the number furthest away from 7 on the scale. For bases, it turns red litmus paper blue. It tastes bitter. You can think of soap. Any kind of cleanser is usually a base. It tastes bitter. It feels slippery. It can be corrosive. It accepts hydrogen ions. It has usually an OH negative ion. It has a pH greater than 7. The strongest is 14. Again, furthest away from 7. So when we talk about acids and bases, they have many uses around the home and in industry. Acids in foods, tomatoes, oranges, they all contain acids. Folic acid needed for healthy cell growth. So acids aren't always bad. And then they also are used to clean, like brick cleaners and surfaces. Hardware stores will sell muriatic acid or hydrochloric acid, which is used to clean bricks and metals. When we talk about acids here, fertilizers have nitric acid and phosphoric acid. And we also have sulfuric acid, which reacts with lead to make batteries. So very, very strong acids here. We have some bases, and bases are primarily cleansers. So you have things like drain cleaners because they contain sodium hydroxide. Notice how everything ends in hydroxide, the OH negative. And they are usually safe. Some of these are safe with your bare hands, and some of them are not. And when you have glass cleanser, when you smell that smell when the house has been cleaned, for instance, then you know you're dealing with a base and you have that ammonia smell. We also use bases in food. So baking soda is a base, and it reacts with lemon juice or buttermilk, whatever, to produce carbon dioxide gas. And that's how we get those bubbles when we have breads and things like that. The table here lists some different acids and bases that we probably are familiar with. Hydrochloric acid we've used in lab, and we have some other acids listed here. We have some cleansers here, sodium hydroxide, potassium hydroxide, and other examples. These are all bases. Notice how most of these end in the OH negative, and all of these start with an H ion. So the strength of acids and bases, strong acids and weak acids act very differently in water. Hydrochloric acid is very strong, but acetic acid, which is like vinegar, is very weak. So you can see the different things going on. In a solution of a strong acid, all the acid molecules break up into ions. In a weak one, fewer of them break up. So you see how these are not broken up. Where here, everything breaks up. So let's talk about the pH scale. 7 is neutral. And the further we get away from 7, the stronger it is. So if it's on this side of the scale, if it's a 0 or a 1, it's a very, very strong acid. And if it's on this side of the scale, if it's a 13 or 14, it's a very, very strong base. Okay, but if it's closer to 7 and it's neutral, then it's probably more like water based. So milk, for instance, is acidic, and blood is on the basic side of things. So a low pH indicates the concentration of hydrogen ions is big, and that means up here. In contrast, a high pH indicates that the hydrogen ions are low. A neutralization reaction, what we do is we take a strong base and we take a strong acid, and we're able to negate the two effects, and we get a neutral solution. When they mix together, it gets closer to 7. So these are some acid-base reactions. Sodium chloride, and each salt here is listed in the table, because what happens when you create I'm going to go back a slide here, hopefully. When you create a neutralization here, you end up with water and a salt. So you can basically boil off the water and you end up with salts. And these are some different salts listed here. And that should be it.